Section 1.3 and 1.4 are about applications and further applications of linear equations. That primarily means word problems. Okay, so we're going to do a brief introduction on how to convert from math to English, English to math, and then we're going to start working through some examples. So here's a handy chart I created when translating from words into equations. So if I have an equation like 2x plus 4 equals 7, right? I said equals. That's how I read that equation. But that's not always going to be the case. Instead of equals, in a word problem, I could say gives, or yields, or is the same as, or is, was, or will be. In addition, I said when I was talking up here, 2x plus 4, but I don't have to say plus. I could definitely ask for the sum. I could say more than. So for instance, this would be 4 more than 2x, or 2x increased by 4. For subtraction, I'm not always going to say minus, right? If I had 5 minus x, I could ask for the difference of 5 and x. I could say x less than 5 or 5 decreased by x. That's how I would read this problem. The same holds true for multiplication and division. For multiplication, I could say times, or I could ask you to find the product. When we multiply two numbers, we're finding the product. I could say twice, that's when you multiply by 2. I could say thrice, that's 3, but that's a weird word, so it probably won't come up. When it comes to division, I could say divide. I could ask you to take a ratio. Remember, a ratio is like a fraction. The key word I want you to remember is quotient, because that one just doesn't feel like as gut instinct. Oh yeah, they want me to divide, right? When I ask you to take a quotient, I'm asking you to divide. So like here's the quotient of 2 and x. So here are some words, how we can translate them to equations. Let's work through a couple simpler examples, just translating from English to math, and then we'll solve a couple short examples and then dive into 5 examples with applications in chemistry and finance and geometry. I hope they are helpful. So if I say the product of 6 and a number is 30, the keywords we should say product, right? Product, that means I'm going to be multiplying, of 6 and a number. I don't know that number. If I say, oh, I should add that to the table. If I say a number, that means I want you to give me a variable. Now, I'm going to use x, but you can really use any variable you wish. I would stick with x, though. So if I have the product of 6 and a number is, that's going to be equals 30. So 6 times x is 30. The product of 6 and a number is 30. 7 less than 3 times a number gives 17. So I know that whatever I have on my left-hand side, it's going to equal, because gives is equal, 17. But it's not 7 minus 3 times a number. It's 7 less than 3 times a number. So that would mean I have 3x, but I want 7 less than 3x, which means I'm actually subtracting from 3x by 7. So be careful to not always read, well, okay, you always need to read from left to right, but you may not be writing the equation verbatim. So let's solve a few examples. So 9 times a number is 30 more than 3 times that number. So if I have 9 times a number is 30 more than 3 times a number, that means 9 times a number, if I've got 3 times that number, and we want to find that number. So 9 times a number is going to be 30 more than 3 times that number. So how would I make this equal? How would I make this equal? Where am I adding or subtracting 30? So if I have 9 times a number is 30 more than 3 times that number, in order to make these equal, I'm going to either want to take away 30 from here, the left-hand side, in order to keep it balanced because it's 30 more than 3 times that number. I'm going to want to add 30 to the other side. It's entirely up to you. 9 times the number is, I'm trying to get my pen to write, 30 more than 3 times that number. So I've got 9x equals 30 plus 3. So if I subtract 3x, I get 6x equals 30. So x equals 5 would be our final answer. We could always check our answer. 9 times 5 is 45, which is definitely 30 more than 3 times 5, which is 15. So we can always check your answers. If the quotient of 3 times the number and 4 is decreased by 3, the result is 9. So the quotient of 3 times a number, that'd be 3x, and 4, quotient means I'm dividing, is decreased by, so that means I'm subtracting 3. The result, so what it equals is 9. So I'm going to go ahead and solve this by adding 3 to both sides. I get 3x over 4 is 12. I multiply both sides by 4 to get rid of that denominator. That gives me 3x equals 48. So x equals 16. So here are my steps to solving word problems. Not just mine, they're also in the text, but here are the steps. So the first thing is to read the problem carefully and slowly. Maybe as you saw as I worked through problems, I underlined important parts like the numerical part or a number that identified I needed a variable. What information is missing? What do we need to find? Next, we want to assign a variable to represent the unknown variable. I would always recommend using X, but there may be a case um, when you need to use 2 variables. So pick variables that make sense for you. Like when we're working with length and width, we're always going to use L and W. Next, sketch it out. Make a table, make a drawing, help you visualize. Even if you're drawing the ugliest triangle or the wackiest rectangle, that is a really bad rectangle. Like draw it out to help you visualize. Next, you want to write your equation, solve your equation, state your answer. Does it seem reasonable? What do I mean by does it seem reasonable? Well, in mathematics, we're trying to um, represent real life. So no, Justin was not driving 200 miles per hour from Kansas City to Los Angeles, right? The baby was not 50 pounds when it was born. You know, the cost of an orange was not $12, right? We're trying to make these mathematical problems represent everyday life. So think, does it seem reasonable? And always keep track of units and check your answer as always.